Hi everyone, and welcome back to Conquering Math, where it all adds up. Today's lesson is an introduction to proportional relationships. Today's learning target is I can use the value of ratios and cross products to determine whether two ratios are proportional. Two variables are considered proportional if their corresponding values always produce the same ratio. Two ratios are considered proportional if they are equivalent. We can use the value of ratios and cross products to help us identify proportional relationships. In example number 1, we'll need to determine whether the ratios are proportional. For this example, we'll be using values of ratios. In A, we have 3 to 12 and 8 to 32. We'll set them both up as division problems and find the values. So 3 over 12 is the same as 1 over 4. 8 over 32 is also the same as 1 over 4. Since they have the same value, this means that the ratios 3 to 12 and 8 to 32 are proportional. For B, we have the ratios 15 to 6 and 20 to 12. Again, we'll find the values of the ratios, and 15 divided by 6 is 5 halves, or 5 over 2. 20 divided by 12 is 5 thirds, or 5 over 3. These don't have the same value, so the ratios 15 to 6 and 20 to 12 are not proportional. Now let's talk about cross products. We can find the cross products of a relationship by multiplying diagonally across the equal sign. You might have also heard of this called cross multiplying. Now, for example, if we have a over b equals x over y, we can first multiply a times y and set this equal to x times b. Whenever we find the cross products of a proportional relationship, the cross products will always be equal. This means that we can use the cross products to help us identify proportional relationships. So now we can use cross products to determine whether the ratios are proportional. We have the ratios 0.3 to 0.25 and 6 to 5. We'll find the cross products, and if they're equal, then we know the ratios are proportional. So we'll start by setting each ratio up as a fraction and setting them equal to each other. 0.3 over 0.25 equals 6 over 5. And we have the question mark above the equal sign because we're not sure if it's true or not. Next, we cross multiply. And so now we have 0.3 times 5 equals 0.25 times 6. If we multiply each side out, we have 1.5 equals 1.5. This is true. So the cross products are equal, so the ratios are proportional. Now let's apply what we've learned to this problem. We need to determine whether the child's age and height are proportional based on the information in the table. In the left-hand column, we have the child's age in years, and in the right-hand column, we have the child's height in centimeters. We're going to use the value of ratios approach because there's 3 different ratios here. So we need all values of h over a to be equal for the age and height to be proportional. So let's start with 107 over 5, which is 21.4. Then we have 121 over 7, which is approximately 17.3. And then we have 135 over 9, which is 15. These 3 values of the ratios are not equal, which means that the child's age and height are not proportional to each other. Now it's your turn to try out this skill. You need to determine whether the ratios are proportional by using the values of ratios method. The ratios are 14 to 6 and 12 to 28. You can pause the video and work on it on your own, and unpause the video when you're ready. Ready? Okay. So the first thing you need to do is set up 14 to 6 as a fraction. 14 over 6 simplifies to 7 thirds. Now set up 12 to 28 as a fraction. 12 28ths simplifies to 3 sevenths. These are different values. That means that the ratios 14 to 6 and 12 to 28 are not proportional. For this problem, you'll need to use cross products to determine whether the ratios are proportional. The ratios are 4.2 to 8.4 and 15 to 30. Pause the video, work it out on your own, and unpause it when you're ready. Are you ready? The first thing you need to do is set the two ratios up as fractions and set them equal to each other. So we have 4.2 over 8.4 equals 15 over 30, and we've got a question mark above the equal sign because we're not entirely sure that it's true yet. So now we'll cross multiply, and we have 4.2 times 30 equals 8.4 times 15. If we multiply these out, we find 126 equals 126. This is true, so the cross products are equal, which means the ratios are proportional. Last but certainly not least, an application problem. You need to determine whether the time you keep a rented DVD and the cost you pay are proportional. Pause the video, work it out on your own, and then unpause the video when you're ready. Ready? You should have found the value of each of the ratios and compared them to each other. It doesn't matter if you did time over cost or cost over time. This time I chose to do time over cost. So first I have 1 day over $1.25, and this is equal to 0.8. Then I did 2 days over $2.50, which is also equal to 0.8. Finally, 3 days over $3.75 is also equal to 0.8. If you put the cost over the time each time, then you would have found a different decimal. In this case, it would have been 1.25, but they all should have been the same. So you'll get the same answer, which is the time that you keep the rented DVD and the cost that you pay are proportional. In today's lesson, you learned to use the value of ratios and cross products to help you identify proportional relationships. Remember that two variables are considered proportional if their corresponding values always produce the same ratio, and two ratios are considered proportional if they are equivalent. Thanks for watching this episode of Conquering Math. You can subscribe by clicking the button below, and you'll get access to more videos as soon as they're posted. You can also head over to conqueringmath.com to find guided notes for this video and to check out all the materials that I have available. Thanks again for watching, and I'll see you next time.